for software like Revit and Bentley MicroStation. What this actually means for your workflow is that you don't have to force an IFC format export if you don't want to. A manager can literally just use the free Revit plugin, click a flagged collision in the report, and the software will automatically cut the 3D view directly to the exact location of that collision right in the native software. It is a massive, massive time saver.
And we're seeing this rigorous approach gaining some serious traction. The webinar notes that over 150 global enterprise clients are currently utilizing this specific software to manage their project data.
When we break down those industries, we can see that this model validation process is truly universal. The clients span across real estate developers, massive infrastructure projects like roads and bridges, the mining sector, oil and gas, and even IT for big data centers. Because at the end of the day, saving time and catching costly errors digitally is a top priority across literally every single major construction and engineering sector.
To summarize the ultimate value proposition here, we pulled this direct quote from the webinar's Q&A session. Clash detection helps us to see all problems beforehand before going to the building site. It's an incredibly simple statement, but it represents millions of dollars in potential savings. By running these automated parameter validations and collision matrices, you're catching the expensive errors in the digital twin, ensuring they never ever happen in the real physical world.
Which leaves us with one final vital question to ask ourselves today. Are your digital models truly ready for the real world, or are they just pretty 3D pictures hiding a bunch of unverified data and costly clashes? If you're aiming to be a high-value VDC manager, your job is to ensure that data is absolutely bulletproof. Thank you so much for joining me for this explainer. I really hope it completely shifted how you view building information modeling.
Welcome to the Explainer. Today, we're bringing you a full-on masterclass on modern building workflows. We're going to focus heavily on exactly what it takes to become a high-value BIM designer and a virtual design and construction, or VDC, manager. We're drawing directly from an incredibly detailed industry webinar that breaks down how top professionals are using advanced platforms, specifically Larix Manager, to completely transform how construction data is validated. It's going to be a great one.
Okay, let's dive into this. And right off the bat, we need to completely shatter a very common misconception. Is building information modeling, or BIM, just a pretty 3D picture? Well, if you ask any industry veteran, the answer is a resounding no. The modern trend worldwide is moving way past just creating a graphical model that we can spin around and look at. A true BIM model, it's a rich, complex database that just happens to be disguised as a building. It's packed with data that we can extract and use to hit incredibly specific goals.
And really, that brings us to true virtual design and construction. You see, a VDC manager doesn't just use BIM as a drafting tool. They use it as the ultimate management platform. They move beyond standard 3D geometry to integrate 4D, which represents those complex project schedules, and 5D, which brings in the actual real-world costs of the building. They're literally connecting the digital model directly to planning, budgets, logistics, and hardcore construction operations.
So here is our roadmap for the explainer today. First, moving beyond the 3D model. Next, essential VDC manager skills, followed by model validation, mastering clash detection, and finally, the Larix Manager Advantage.
Let's jump into Section 1, Essential VDC Manager Skills, focusing on the core competencies.
What does it actually take to manage the common data environment on these massive projects? Well, while we are definitely getting highly technical today, this source material highlights a major shift in the industry. Technical expertise alone just isn't going to cut it anymore. Today's high-value VDC manager absolutely must have incredibly strong collaboration and communication skills right alongside sharp management capabilities. You're basically orchestrating vast amounts of data across totally diverse teams, architects, structural engineers, builders, and your job is to make sure everyone is working from a single, reliable source of truth.
Moving on to Section 2, Model Validation and Verification. Think of this as the digital twin health checkup.
Think about it like this. Just like a doctor wouldn't dream of operating without checking a patient's vitals first, a construction team absolutely cannot build based on a model without verifying the underlying data. The source outlines a really clear step-by-step workflow for using Larix Manager to validate an information model. Step 1 is the visual check, ensuring elements are properly classified. Step 2 is documentation reconciliation, which means making sure your PDFs and 2D specs actually match the 3D model data. Step 3 is LOI, or level of information validation. And finally, step 4 is automated clash detection. Let's see how these actually play out in practice.
During a visual check, one of the biggest headaches is filtering the noise. Imagine you need to estimate costs for just the concrete walls. In a massive, complex model, how on earth do you find them all? The webinar shows how you can use Larix Manager to stack filters. So first, you filter by the IFC class for walls. Then, you add a condition that the material name must contain the word concrete. And finally, you add a crucial exclusion to hide coverings. This translates a software feature into a universal data management principle. Precision filtering is quite literally everything. And this brilliantly illustrates what happens when we group these elements by specific parameters. Let's say you group all your walls by a parameter called location story. Suddenly, boom, you spot a glaring error. A wall that physically belongs on a lower floor has accidentally been assigned to level 13. By running this parameter check, you isolate that mistake digitally, generate a quick element list, and send it straight back to the designer to fix before anyone lays a single physical brick. It's a huge save. Okay, once the visual and structural checks are done, we move to step 3, level of information, or LOI. Now, this isn't about geometry at all, it's about making sure the data types and values are actually correct. For instance, Larix allows you to set a hard rule that the numeric area of a wall must be strictly greater than 0. If the parameter for the net side area is missing entirely, the system flags it automatically as a mistake. It essentially guarantees that every single required parameter is actually filled in.
Section 3. Mastering Clash Detection. This is where the digital world meets physical reality.
Now that we've checked the parameters, we're moving into physical reality. Clash detection generally falls into 2 main buckets. First, you have interdiscipline clashes. These happen between different teams, like when the architecture model puts a door exactly where the mechanical team placed a massive ventilation shaft. But Larix Manager also handles intradiscipline clashes with total ease. That means checking for intersections within the same discipline, like structural beams clashing with other structural beams, or maybe windows colliding with other windows because of a simple duplication error.
Now, interestingly enough, clash detection isn't just about 2 physical objects bumping into each other. Think about regulatory collisions. This is where you're enforcing complex project decisions. You can automatically check if a wet room was accidentally placed directly above a residential bedroom, which is a huge no-no. You can check for minimum clearance heights in rooms, the minimum required distance between parallel pipes, or even flag an error if they're missing holes in the concrete slabs. It's really about validating the actual design logic. Which brings us to Section 4, the Larix Manager Advantage, focusing on elevated workflows. So the crucial point is, how does a modern platform actually elevate the day-to-day workflow? Well, the source notes that traditional tools like Navisworks offer about 2 types of collision checks and really rely heavily on manual visual checks for parameters. Larix Manager, on the flip side, offers 7 validation types, fully automated parameter checks, and this is the real game changer, native editing. If a VDC manager finds a missing parameter, they don't have to pause everything and wait for the designer to upload a brand new model. They can just add and edit that parameter right there in Larix to keep the whole project moving forward. The source also heavily direct plugins for software like Revit and Bentley MicroStation. What this actually means for your workflow is that you don't have to force an IFC format export if you don't want to. A manager can literally just use the free Revit plugin, click a flagged collision in the report, and the software will automatically cut the 3D view directly to the exact location of that collision right in the native software. It is a massive, massive time saver. And we're seeing this rigorous approach gaining some serious traction. The webinar notes that over 150 global enterprise clients are currently utilizing this specific software to manage their project data.
When we break down those industries, we can see that this model validation process is truly universal. The clients span across real estate developers, massive infrastructure projects like roads and bridges, the mining sector, oil and gas, and even IT for big data centers. Because at the end of the day, saving time and catching costly errors digitally is a top priority across literally every single major construction and engineering sector.
To summarize the ultimate value proposition here, we pulled this direct quote from the webinar's Q&A session. Clash detection helps us to see all problems beforehand before going to the building site. It's an incredibly simple statement, but it represents millions of dollars in potential savings. By running these automated parameter validations and collision matrices, you're catching the expensive errors in the digital twin
ensuring they never ever happen in the real physical world. Which leaves us with one final vital question to ask ourselves today. Are your digital models truly ready for the real world, or are they just pretty 3D pictures hiding a bunch of unverified data and costly clashes? If you're aiming to be a high-value VDC manager, your job is to ensure that data is absolutely bulletproof. Thank you so much for joining me for this explainer. I really hope it completely shifted how you view building information modeling.
Welcome to the Explainer. Today, we're bringing you a full-on masterclass on modern building workflows. We're going to focus heavily on exactly what it takes to become a high-value BIM designer and a virtual design and construction, or VDC, manager. We're drawing directly from an incredibly detailed industry webinar that breaks down how top professionals are using advanced platforms, specifically Larix Manager, to completely transform how construction data is validated. It's going to be a great one. Okay, let's dive into this. And right off the bat, we need to completely shatter a very, very common misconception. Is building information modeling, or BIM, just a pretty 3D picture? Well, if you ask any industry veteran, the answer is a resounding no. The modern trend worldwide is moving way past just creating a graphical model that we can spin around and look at. A true BIM model, it's a rich, complex database that just happens to be disguised as a building. It's packed with data that we can extract and use to hit incredibly specific goals. And really, that brings us to true virtual design and construction. You see, a VDC manager doesn't just use BIM as a drafting tool. They use it as the ultimate management platform. They move beyond standard 3D geometry to integrate 4D, which represents those complex project schedules, and 5D, which brings in the actual real-world costs of the building. They're literally connecting the digital model directly to planning, budgets, logistics, and hardcore construction operations.
So here is our roadmap for the explainer today. First, moving beyond the 3D model. Next, essential VDC manager skills, followed by model validation, mastering clash detection, and finally, the Larix Manager Advantage.
Let's jump into Section 1, Essential VDC Manager Skills, focusing on the core competencies.
What does it actually take to manage the common data environment on these massive projects? Well, while we are definitely getting highly technical today, this source material highlights a major shift in the industry. Technical expertise alone just isn't going to cut it anymore. Today's high-value VDC manager absolutely must have incredibly strong collaboration and communication skills right alongside sharp management capabilities. You're basically orchestrating vast amounts of data across totally diverse teams, architects, structural engineers, builders, and your job is to make sure everyone is working from a single, reliable source of truth.
Moving on to Section 2, Model Validation and Verification. Think of this as the digital twin health checkup.
Think about it like this. Just like a doctor wouldn't dream of operating without checking a patient's vitals first, a construction team absolutely cannot build based on a model without verifying the underlying data. The source outlines a really clear step-by-step workflow for using Larix Manager to validate an information model. Step 1 is the visual check, ensuring elements are properly classified. Step 2 is documentation reconciliation, which means making sure your PDFs and 2D specs actually match the 3D model data. Step 3 is LOI, or level of information validation. And finally, Step 4 is automated clash detection. Let's see how these actually play out in practice.
During a visual check, one of the biggest headaches is filtering the noise. Imagine you need to estimate costs for just the concrete walls. In a massive, complex model, how on earth do you find them all? The webinar shows how you can use Larix Manager to stack filters. So first, you filter by the IFC class for walls. Then, you add a condition that the material name must contain the word concrete. And finally, you add a crucial exclusion to hide coverings. This translates a software feature into a universal data management principle. Precision filtering is quite literally everything. And this brilliantly illustrates what happens when we group these elements by specific parameters. Let's say you group all your walls by a parameter called location story. Suddenly, boom, you spot a glaring error. A wall that physically belongs on a lower floor has accidentally been assigned to level 13. By running this parameter check, you isolate that mistake digitally, generate a quick element list, and send it straight back to the designer to fix before anyone lays a single physical brick. It's a huge save. Okay, once the visual and structural checks are done, we move to Step 3, Level of Information, or LOI. Now, this isn't about geometry at all. It's about making sure the data types and values are actually correct. For instance,
Larix allows you to set a hard rule that the numeric area of a wall must be strictly greater than 0. If the parameter for the net side area is missing entirely, the system flags it automatically as a mistake. It essentially guarantees that every single required parameter is actually filled in.
Section 3. Mastering Clash Detection. This is where the digital world meets physical reality.
Hello everyone, let's start our second lesson, and I'd like to show you which materials we need for the second lesson. Please look for materials of the first lesson, and we need from there open sample Autodesk for Revit 25, and there we need to open an architectural model. That's all, only one model. It will be a sample of our plugin, how to import the parameter changes. And let's go to the materials of the second lesson. And please open in Larix Manager the model RVT plus IFC. I will show you how to do it, and then we will start our lesson. Let's open Larix Manager. there will be the first window. You need OK, and then you need to create a new project. OK, and open project. Now I see an empty project, and I need to add my IMC model. RVT plus IFC. Please find this in our archive for the second lesson. And open. And today we will work with RVT model and IFC. And I will show you how to work with these different datas. That's okay. Let's start from our presentation and then we'll do some practice. On the first lesson, we will do an assemble of federated model and do some visual verification. And today we will do data checking and manage our information in model. Today I'd like to show you how to do automatic verification of parameters availability and complexion. Also, I would like to talk about checking the filling of parameters, about methodology for working with a raw model, mapping the parameters of the consolidated model, creating sets, and show you the difference from Navisworks, and creating a consolidated specification, import adjusted values into Revit, using our plugin on Revit, and verification of design solution and modeling errors checks. Also, we will do a parameter report. That's our plan. And I'd like to start from some speech. Thank you for your responses and feedback. It's very vital for our team. It makes our product better. And the most interesting information in the first response was your choice of software. And here you can see each software use all participants of our classes. Here you can see the CAD software and the model checking software. And if you have never learned before about Navis or Revit, Autodesk Model Checker, or the Open IFC Viewer, here you can see the links on this software. And I see that you need to see some comparison. So let's talk about what's the difference between different software that you use. As I see Navis Order and Model Checker, let's see the difference between these software. Well, Model Checker, it's only for Revit, and you can check only parameters. That's why it's not complicated checking, and it's not enough to do the complicated checking. So let's see Navis and Open IFC Viewer. The main difference between them that Navis can open IFC, RVT, and many different formats. Open IFC Viewer can open only IFC formats. Also, Navis can't check parameters in automatical mm, can do automatical checks. Open IFC viewer can, but there is no flexible verification setting. And if we are talking about collisions, there are only two free collisions types of checks. And here you can see some functional abilities of this soft there. Let's continue and see the details of the interface and some abilities of this software. This viewer can work with IDs, but there are no user checks like in Larix Manager. And you can do after validation of parameters only TXT or HTML report. In Larix Manager, we can do Excel, very flexible type of report. If we are talking about collisions in OpenIFC viewer, there are only two types, intersection and clearance. There is no user filters. As you see, you can select only some entity of our tree viewer. You can't do your user filter to select and check collisions of these elements. Reports in BCF format, so you can't export to Excel or another format. There is no statistics, no analytic tools. It's a quickly type of checking, but not professional. And let's find the difference between Larix Navis and OpenIFC viewer. If we are talking about collisions, in Larix Manager there are 7 different types: intersection, medium distance at projection on axis X, location validation, duplication, and presence in volume. In Navis, in Open Viewer, there are intersection, of course, duplicates, and clearance or minimum distance. That's all. But I'd like to say about some speech in our community. There are many talks about how Navis counts the size of collision, how it counts the distance between elements. You can read, you can tag the link and see more information about this question. So our BIM community think that this instrument isn't correct. And the total show, let's see the short comparison. Larix Manager and Navis can work with IFC and RVT. It's very comfortable and flexible for BIM managers. As I told before, OpenIFC Viewer works only with IFC. Larix Manager can check parameters and collisions. Navis only collisions, and OpenIFC Viewer parameters and collisions. But Larix Manager is a professional, has professional features that can be flexible, customized by the user. For example, some filters, reports, and model free. As we are talking about Navis, there are only settings for filters, and OpenIFC Viewer isn't flexible at all. Larix Manager and Navis can do collision analysis, prioritization, statistics, show our statistics on the project, and you can put some comments on collisions. If we are talking about OpenIFC Viewer, there is no collision statistic. If we are talking about Larix Manager, there is no IDS and BCF. It's only our plans In Navis, there is no IDS, there is BCF, and in OpenIFC, there is BCF and IDS. And what about my choice of software for working with these models? Then I was a designer. Then I was working in Revit every day. I was using Model Checker. Here you can see the model sample and some examples of verification checklist using this plugin. There are different checking, for example, duplicated elements. You can find duplicated elements, parameters which are not exist in elements. You can check file size, area space schemes, volume of elements, and different work sets, and another different things that are vital for designers who work in CAD systems. But if I am talking about a role of a BIM manager or product manager like I am, I use two software for different tasks. I use Larix Manager is I need to do a full model verification, and I need to manage data in my models. And I use Open IFC Viewer if I need to understand the structure of IFC. If when we are working with IFC, let's see the example. Let's open, for example, some samples from the first lesson. One second. For example, I'd like to show you clinic architecture IFC, and I'd like to open with Notepad++, because IFC is because it's the because Notepad++ can help you to see the structure of IFC, but it's very complicated, and you need to understand all text zones of all entities of IFC, and it's rather difficult. It needs very high qualification. So, for my opinion, Open IFC Viewer can help to understand it quickly. For example, I can open some model IFC and see the tree viewer of a selected element. And now I can see all information about IFC wall. In Notepad++, it will be different positions in our text file, but here they can see all necessary information in one place. And here I can very easy find the parameters, the property set of elements and values. That's why then I need to understand the structure and make some tasks for my colleagues who develop some new features. I use this viewer. But today we will talk about Larix Manager and professional checks of parameters. So we will talk about checking the parameters, adjusting the model data, parameters mapping, checking, and for the next session, we will talk about checking for hard and soft collisions and do collision analysis. And let's repeat how to do the federated model. As I told before, we can import IFC and also import IMC from Revit, for example. And let's work with IFC and IMC in one file, in one federated model. Let's go to the practice. One second, please. I will open the empty like you and show you how to do some first settings. For example, it will be comfortable to add IFC model to one folder and RVT to another folder. Let's do the next profile editor, the next profile item. Let's use this feature and now add a new profile. Now we have the first model profile and new profile. Let's go to a new profile. Okay. And here I can add some folders. For example, for IFC models and for RVT. Just it will be more comfortable to work if we will separate models in different folders. So, Zuffa, you would like to say something?
No, I'm sorry.
And now I can put IFC models in the folder IFC and RVT. And now they can see two folders. Let's look for the check-in box. If there won't be a check, these models won't be using in our visualization and the checkings. So let's firstly see only IFC models. So let's put a check. And now we need to refresh our data. And then we will see the elements of our 5 models of IFC format and see the visualization of our models. Then I'd like to show you how to work with sets which I sent you in materials. Let's see. Materials of the second lesson, and there is a file, all sets. Please copy the placement and go to the profile editor here and then import our profile, all sets. Okay, and now I will work with this set. So it's like it's in Nevis, we can save our sets and use on different projects. It's the basic simple of sets if we are working with IFC model. For example, there is sets of architectural models of electrical, HVAC, plumbing, structural. If I put twice, I will visualize all elements of these sets. And as you see, elements, changes, and visualization. And there is a support set that can help you to see which elements are not counted in our sets. It's the general. In all models, which elements are not accounted. And I do the model, there all elements are in some sets. That's why there is 0. It's okay. It's correct. But if we will add another model, for example, let's check RVT models and refresh our data. It's the last button. And let's go to the sets again. And now go to not accounted elements. Um, uh, Architectural. One second, please. Maybe because there is the sample. Yes, there is the sample name architectural in RVT and IFC. That's why my set doesn't think that it's new things. And let's see these sets. And here you can see the elements of IFC elements and RVT. That's okay. But if I will add some new discipline, there will be some elements which are not accounted. Well, let's uncheck RVT models and refresh datas again. Let's go to the sets. And now I'd like to show you how to do a quickly profile of parameter checking. After our we need to convert parameters validation profile. It's the last button. Буква, it's let's use this feature. The profile created successfully, and now I am going to the next mode, validating parameters. And now I see the same profile with the same name like our set profile. So here I can do some changes. For example, I am not interested in not accounting. I can delete these things and works, for example, with structural elements with construction. Entities, it's sets of some entities of IFC, IFC building story, IFC site, IFC project, the entities of our tree viewer. It doesn't interesting. We in validation of parameter we can delete and use and work only with construction elements: IFC slab, IFC wall, IFC stair, all elements which build our model. And here we can see the editor. There is the filter, which is the same in the profile of sets. And here we need to add only validating condition. And that will help us to find parameters which are empty or not, which exist not exist in this file. So let's do checking of IFC slab and find some parameters. How to add a parameters in validation condition? we need to open a window which named like parameter reference. And find, for example, parameter element specific elevation, for example, and use the right bottom of your mouse and click here and again and repeat. And after you need to add the parameter to the not filter condition, it's the first, to the verification condition, the second. And now we see we have a local validating condition. So what does it mean? That the check only elements with IFC class which is equal to IFC slab and find the parameter which is name elevation in a number in set like element specific. It's a basic IFC parameter. And let's save and one moment. Let's add it to the fields too, like these fields, and save. Now let's do our checking on the third button in this validation template. And we see that we have a result. Let's click twice and see verification result. If you will click one, you will see only the editor. But if you want to see the result, please tap 2 times. And here you can see the result. 13 parameters wasn't found for elements. All IFC slabs doesn't have this parameter. So using this tool, they can find parameters which are empty or not found in model, not found at model. Also, we can do more complicated checks. For example, in your requirements, there is a table with with available values, so we can check it automatical too. For example, let's check another parameters. For example, no, the most simply it's about numeric parameters. For example, we need to check the height of element, for example, for IFC wall. Let's add two verification condition. And for fields, let's save. And here I'd like to change the operator, not a star. Let's use more than 0. So if the parameter will be 0, it will be a mistake too. Here you can add any height in millimeters. Let's use 0, save. And let's check. Let's see the result. Here the parameter is not found. Let's no, there is no this parameter. Okay. And another checking, they can we can check maybe some materials. Yes. Let's go to the validation parameter editor. And here will be some settings, how there I can write available values for different parameters. For example, I'd like to check this parameter. I will add this to the condition and save and go again to the editor of validation parameters. Now I see these parameters in profile parameters. What's the difference between library parameters and profile parameters? In that center, you can see all parameters in all models in every models which I have. And parameter profile, it's only parameters which I have add to our validation template. So we are working not with library, we are working only with profile. We can it's vital. Then I can write some values. For example, okay. For example, all walls must be must have material only brick, and another values can be in model. So I can save these settings and let's check it again. I was working with structural construction and IFC wall. Okay, and now let's check. Let's see the result. And now we can see a new type of mistake. Some elements doesn't have the first parameter, and some not found. Maybe let's do better checking. I will look which parameters are on elements, because maybe I use not necessary parameters. Let's see. I'd like to look construction model. Let's see this set and see the parameters of some walls. If and the walls, construction walls. And let's see, is there a parameter of material or not? Yes, there is, but its name in another way. Let's see another parameters. Maybe let's use set wall common reference. So let's go to parameter profile and delete this parameter and add that which we have copied before and add to verification reference. And I'd like to find walls which are not concrete, which are not brick, which are concrete, for example. Let's save. I also, yes, and let's check. I forget about fields. Let's add to the fields too. Save and again. And see the result. Now, and I don't write. It's another parameter, so I need again go to the editor and write available values, for example, brick. Brick, okay. Close. And go to the structural, construction, and IFC wall. And let's check again. And now I will see the result with mistake of value. Yes, let's see. We have some elements with parameter value which does not match the specific range. Because let's see the material. Here material doesn't have concrete, doesn't have brick. It's a concrete walls. That's why it's a mistake. Well, okay. So using these feature, they can check our model according to any requirements. And how we will see the report. Let's make an Excel report. Here you can add any parameter you like. For example, I'd like to add a material of my my walls. Maybe some information about IFC class, not IFC class, some no, any you want. For example, element specific tag. It's a unique ID with which can help you to find element in Revit, for example. Okay, and let's save. And see the result. You can use filter in Excel, and here you can see IFC class, model, ID element in Larix, ID in Revit, element specific tag, the last column, and parameters which are not correct and why there are error types which can help you. And also if there is a mistake with value of value out of range, so you can see the current value for this element. So it's enough to designer to find this element in model and check their parameters. But if we are talking about models with RVT formats, let's go to the first mode, viewing the model, go to the Project Explorer models, and let's switch off all our IFC models and switch only RVT models. And here you can see another building. It's only architectural model. And here I'd like to see how to do a quickly removing of our parameters. For example, let's see some elements, for example, wall. And here you can see some parameters: area, length, category, material, information of every compounds element of a wall, and and some types parameters. Mhm. Так, one moment, please. I'd like to find some text parameter and check it for value. For example, let's check maybe some comment. Yes, I can find. It's null. It's null. As you see, there is a parameter, but it's empty. And if I need some more information, I can add some new parameter, or I can rewrite some values. For example, for this element, I can create a new parameter or overwrite values. For example, I can find this parameter. Here is it. Let's use this parameter and write some value for this parameter. New value, for example. Okay. And now we have a data in this parameter. Then let's check. No, for example, let's go to the validation parameters. And now I'd like to do a new parameter validation and check only RVT models. How to do it? Let's add, let's use a new parameter validation and check comments. Check comments. Okay. I'd like to check not all model, but only, for example, walls, like I see before. So I need to filter my elements by IFC class or category if they are talking about RVT. So let's find category in parameter reference and add to verification condition. Here they can see to the filtering condition, to the first. And now I'd like to choose only IFC wall. So let's show possible values and find walls. Okay, and I'd like to find a parameter comments. Let's add it to the verification condition. Okay, and to the fields. Save. Let's check. And here we can see that one element is valid and all others are invalid. So how can they solve this problem if it's a basic parameters which need to be according to our requirements? They can select all our elements which are invalid, the last window. And here they can do a list of this element, or they can take the right button and overwrite our values. For example, okay, comment, comments and slash maybe without yes, comments. I found this parameter Okay, and now I can overwrite values to solve this mistake. New value, for example, just for some to show you how to work with this technology. Okay, and now let's check again. Now it's correct. And how to import these um, mm, these mm, overrides of our values to the Revit. Let's go to the first mode, viewing the model. And here they need to find our model where the override parameters. And here they need to use and here we can export list of alternative values. Let's do it. To Explorer, and it's export list, for example, number 2. Let's save. Let's wait while the report will be done and open our Revit, this model, to import these new values. I am working in 25th Revit, and I have already opened architecture model. The report is finished. Let's go to the report, to the model. And here we need to open add-ins. I see your feedback about Russian some plugins. I'm sorry for this naming. We will change it. And for the end of our education, we will send you the correct plugins, and I will rewrite a video about these plugins because I understood that it's very hard to understand in another language. We will I will rewrite it. But now I just show you the logic. We used the import of our list, and now I can see all walls which have new values. And here I can see that I have new values more than 1,000. And I can check all elements or not all. You you analyze and then put a check what you want to import. Let's see before export. Let's see this element. Manage, select by ID, and put this ID. And here I can see that comments is empty. Let's import our new values again. For example, I put everywhere and import. There is some groups. I don't want to change it. For example, let's change one element. Okay, import list and which was interesting for me. 5221. 105. Let's work with this parameter, this element, for example, and import only for this. Okay, and let's search this element. select by ID, okay. And now you can see that the parameter is rewriting. So it's very quickly to check all parameters in Larix Manager, find which are not in model and add them, and which values are not correct in Larix Manager, and import these changes in Revit. It's only for RVT models. For IFC, we don't have such opportunities. Well, okay. But how I can work with models which are IFC format and RVT? Now models are not coordinate, so visualization is empty. It's okay. It doesn't matter. I'd like to talk you how to work with tree viewer of our model, because they have in IFC model we have IFC class, so all RVT models will be no value because there is no IFC class, there is category. So we need do mapping where will be a new parameter which is equal to IFC class or category. So let's do it. We have a feature adaptation which can help us. Now let's import my file. Let's go to the materials and export general attributes XML. Again, adaptation, general attributes, and here I can import from Explorer general attributes. Okay, and after you will see 3 groups of parameters. Geometry, where you can see numeric attributes area and volume, identification, string attributes with name, conditions, constructions, and location, string attribute with name, level. Okay, let's close. And then we need to go to adapters. There here we will do mapping. Let's import my file of mapping. It is name like new adapter. It's XML open. We have a new adapter and let's open it. The first, you need to select a model to connect to the adapter. It doesn't matter. Let's choose firstly IFC model. The first, for example, architecture. And now we can see our settings of mapping. And here I do some attribute bindings. For example, from IFC, I took element-specific gross flow area, set Revit dimension area, set Revit type other area, and etc. And from Revit, let's select another model. Please click here on the cube and select another model which is format RVT. Okay. And cancel. And from this model, I add area and material area. And for another parameter, attributes the same story. So I can do mappings of any parameters which are in our models. And what I will see as a result, let's save, close, close. And now I need to do adaptation. How to do it? I need to choose my model and in editor, add a new adapter. Okay, and save. It's vital. Don't forget about saving. And then I can apply adapters to other models in my project and select all models. Okay, now I see that in the editor I have my new adapter on every model. And then I need to adaptate my model. I need to select my models and click on adaptation, the third button in the end of a line. And the last one. Now we see the black indication. It means that the adaptation is successfully completed. And now we need to refresh our data in database. And now in parameter reference, we see not only expert parameters, but also adapter parameters. Geometry area, geometry volume, location, and identification construction. And if we will see just one element, for example, IFC space, here we can see the adapters for just this element, and here we have geometry area and identification name IFC class. Let's go to the structures and see the result. Here, you need to work not with the temple IFC. They need to import a new profile, which was in materials of our lesson. Let's use it. It's called as tree viewers. Let's import this temple. There could be doubles. Let's delete the first structures because I have some changes in IFC and RVT. And open mapping tree viewers. And what we can see. We don't see no data, no value. There is the correct names of element. And let's see IFC wall. And what we have here. Let's group by IFC class. And we see that not every element has IFC class because these elements are from Revit. They don't have this attribute. How I do this reviewer, which join category and IFC class in one tree viewer. Let's see the editors of our new structure. Let's click on the high high level of our structure, new structure, and see the editor. And here you can see that I group my tree viewer not using IFC class. I use an adapter, identification construction, which is equal to IFC class or category. That's why my elements from Revit and IFC now are in one entity. And here you can see elements are divided into levels. And also you can see the mapping of area, because in Revit there is the parameter area in IFC set quantities area or another, for example. And I see that let's do more bigger, and I see that there is no empty empty parameters. All elements were successfully adapted. And I can zoom area of all walls from IFC and RVT. This is the way how to work in different software, like I showed you before. For example, then you have some models in Tekla and in Revit, for example, and you need to work with IFC and RVT format. Well, let's talk about specification. Let's do more complicated specification in the window elements. Now I count area, but I'm interested in, let's clear grouping. I'm interested in materials too. Let's see, there I can find this information. Maybe reference I will take. Mhm. Let's work not with IFC wall, let's work with IFC slab, it's easier. I think, yes, it's concrete plate. I can use, for example, object type. I think it's enough. So let's add this parameter. IFC slab. Let's click on the new structure and add to the fields new parameter. I can do it in the parameter values. Click by the right bottom and add to the fields, or I can add by plus on this editor. And let's save. And let's open IFC slab again. And now I see the last field, object type. And here I can see not only I can see the thickness of element and material. So it's more complicated specification, like in Revit, there are some levels, but the difference between Revit and specification in Larix, you can do any levels you want. It's maybe 5 levels or 10 levels, it doesn't matter. For example, object type, IFC, category, etc. And there is, it doesn't matter. It's possible to do any structure you need. Let's come back. And this information I can export to the report in Excel area. And now let's see the result. And here you can see the specification. Some elements doesn't have this parameter. But here we can see the specification with different levels. The first is grouping by material and thickness, and then some elements. So you can do any specification you want with every construction, with every parameters which are in model. Okay. Let's see our plan for today. We talk about automatical verification. Так, I will show you. We talk about automatical verification, about checking the ceilings, values of our parameters, methodology, how to work with raw models. Then we don't have necessary parameters, how to do a new one. Let's show you how to do a new parameter. For example, I'd like to add a new parameter for slabs, and I can create parameter. In code, I will write a name of this parameter, for example, some new param, like a sample, and value, new value. And now you can see in parameter values the new column custom parameters, and here you can see new data. So if you don't have time to wait until the designer will add some information, until he will correct some datas, you can do it by your own without help of designer. You can do it in Larix Manager. So in this software, you can work with data. For example, if you are a builder, you need some unique parameters which designer doesn't doesn't add to models. So you don't work with Revit, you can work with Larix and add necessary parameters here. The next point, we were talking about the mapping of parameters, how to create sets, and what the difference. Let's talk about the difference between Navisworks and set of Larix Manager. Firstly, you doesn't need to copy the main condition. For example, if we want to select walls, doors, coverings of architectural models, we doesn't write that these elements are in the model of architecture. We just need on the high level do a filter. There we will write which model we need to choose and create a set into this set. And the wall will we will see that the program inherited filters conditions. So it doesn't need to copy it in every set of construction. Then what is the difference? When we were working with Navisworks, sometimes we need to do a set of, for example, pipes with diameter less than 100 and more than 100. So it was difficult to do in Navisworks because there are different parameters with diameter, and it doesn't understandable which parameter I need to select. It's in Larix Manager, there is no of these problems. There is all parameters like in Revit, like in IFC. It's correct. And the editor is quite flexible. As you see, I can do very complicated filtering. For example, I can use all, или, or not. I can group some filtering. For example, this filter show me elements which are not accounted. So I do a filter which doesn't select all elements in architecture which I use in sets, all sets. So here you can do any logical condition you like. It's very flexible. That's the main difference. When I show you how to do a consolidated specification using element, how to sum some parameters, how to import adjusted values into Revit using our plugin for Revit, and how to verify the design solutions. As I told before, in the mode of validation parameters, they can not only find an empty parameter or which isn't in model, they can also check, as I show you, that all numeric parameters must be more than 0. For example, if we will check architecture element IFC space and find geometry area, I think, to condition and to the field, and write that must be more than 0. We will see the space which are not correct in our model. Let's see the result. And here all spaces has value more than 0. So it's correct. So using this feature, they can checking, for example, the length of stair, the width of stair, the height of some elements, and another numeric parameters. And I show you which reports they can do. Also, they can do BI reports. What the difference between the first result and the second? The first shows only invalid parameters, but the second will show you valid elements too. So you can do dashboard with the percent of successful and not successful checkings. For example, you can open this BI report in Power BI and do some dashboards. So that's all for today. I hope you will write your feedback about our class, our second class, and if you forget about responses after the first, please write. It's vital for our team. Thank you for attention.
Okay, thank you, Anastasia. I'm sorry for the connection issue from me earlier, which kept me from being on camera and starting smoothly. And now we're entering the Q&A session. Kalau dari rekan-rekan ada pertanyaan, boleh disampaikan di room Q&A atau boleh juga dikirimkan ke grup peserta, mana nanti bisa kami bantu untuk sampaikan ke Anastasia atau ke instruktur. Coba kita cek. Let's check the Q&A box if there is any question. Okay, there's no question until now from the participant. Oke, kalau belum ada pertanyaan, tidak apa-apa, sekedar mengingatkan untuk teman-teman yang belum presensi, yang belum mengirimkan feedback, atau yang belum mengisi kehadiran yang bisa dikonversi ke PKB, silahkan mengisi form yang sudah dikirimkan di room chat. Dan pastikan teman-teman mengisi feedback ya setiap sesi, karena nanti di akhir sesi akan disampaikan akan ada pemenang yang atau salah satu teman yang beruntung dan mendapatkan free access 1 bulan secara gratis untuk menggunakan Larix Manager. So, karena there's no question, Anastasia, and with that final question, there's no question. We have reached the end of session 2 of our Larix Manager. So I think that's the end for today. Massive thank you for you for the comprehensive explanation and for the insight, and a huge round of applause to our participant. And yeah, see you tomorrow for the next third session. Thank you, everyone.
Goodbye.
Okay, goodbye.